que toqué fue la 0.10 en el 2013 y trabajé con él desde 2000. Bueno, yo era el tipo de persona que me gustaba trabajarlo, llevar a la contraria a los maestros en la universidad y me ponían proyectos en PHP o C# y yo quería hacerlos con Node.js y pues así fue como aprendí. Es un lenguaje que le tengo bastante cariño, la verdad, JavaScript, y como tal Node, porque fue realmente el lenguaje y el motor con el que yo aprendí a programar. O sea, a mí me estaban dando Java, no le entendía, se me complicaba, o tal vez era una cosa de los maestros, quién sabe. Entonces Node.js se me hizo como que mi liberación y donde pude aprender yo realmente a programar, ¿no? Entonces, bueno, esas son algunas fotillos que yo alcancé a rescatar. Como dato interesante también, bueno, no sé si alguno de ustedes le alcanzó a tocar el callback hell. Si no saben qué es, entonces de plano son relativamente nuevos en JavaScript o en Node, que era que si tú querías hacer procesos asíncronos y devolver esas, por ejemplo, a mí me tocaba trabajar con transacciones, antes no existía el await, JavaScript es un lenguaje asíncrono, entonces te pasaba que tenías que hacer callbacks con promesas para poder hacer múltiples procesos y esperar a que cada uno termine y hacer cuantas veces sea necesario para poder terminar una transacción. Entonces, ahorita eso ya no existe, ahorita ya nada más es async await y ya espera todo y eso es listo. Entonces, ya viven en una época más feliz de JavaScript. Comento estos temas porque, bueno, el tema de mi experiencia más que nada, porque este proyecto que les voy a comentar es un punto de inflexión en mi carrera. Esto pasó en el 2018 y prácticamente fue como cuando comencé a trabajar en este proyecto, fue cuando hice un cambio yo de mi especialidad en la industria. Yo era como un full stack software engineer y debido a esto me pasé al lado de datos. Entonces yo comencé trabajando en la industria petrolera en Tabasco, principalmente para el procesamiento de datos sísmicos. Esa imagen que ven aquí es una imagen que yo generé con trazas sísmicas, con un software que ellos, no me acuerdo si era ArcGIS me parece que es. Y parte de ese proceso para generar estas visualizaciones las hicimos con Node.js. Fui algo más como, no desarrollo, sino más de investigación, más researcher. Entonces me tocó trabajar Node.js con embeddings de C++, y con eso logramos generar como estas imágenes de trazas sísmicas. Así estuve los primeros 2 años, ya como profesional de la industria, desarrollando proyectos web, esa parte de visualización. Era más que nada experimentos. Yo no estaba acostumbrado a desarrollar sistemas ni nada de eso, pero sí sabía, por ejemplo, la parte del desarrollo de aplicaciones con MVC, ¿no? Model View Controller, que es que tienes el backend, se conecta al frontend por medio de una API y ya tienes como que tu frontend escrito en JavaScript. En 2018 me toca la oportunidad yo quería estudiar una maestría y me sale la oportunidad de conocer al CTO de una startup que fue fundada en Arabia Saudita. Él es cofundador de la startup y ellos traen un proyecto para todo lo que es adquisición de datos para generar alertas contra inundaciones, generar brigadas para inundaciones, capturar datos de calidad del aire y de tráfico. Y ellos en 2017 ganaron un founding en una universidad de Arabia Saudita que se llama KAUST, es King Abdullah University of Science and Technology, y ganaron no me acuerdo cómo se llama el fondo, pero les dieron $1 millón por el proyecto de los sensores. Tenían únicamente los sensores, no tenían como que la plataforma, ¿no? Entonces, en 2018 me toca conocer al CTO. Al CTO le presento mi proyecto de maestría, que yo quería que estuviera en una maestría, y resulta que encajábamos perfectamente, y a los 2 meses que él se enteró bueno, que yo le platiqué de mi proyecto, me dice, ¿qué quieres? Me mandan un correo básicamente diciéndome, ¿quieres hacer tu proyecto de maestría? Ya tenía la beca todo asegurado, lo puedes hacer con nosotros, pero tenemos una necesidad de software, entonces no haces el software y terminas trabajando con nosotros, pero como mi beca era del CONACYT, o era la beca o era el trabajo. Entonces, pues le di crán a la beca y preferí trabajar con ellos. Entonces, en 2018 comencé a trabajar para Sadim. Y pues aquí, ¿no? Una cosa me llevó a la otra, presentamos el proyecto, les ayudé a presentar la plataforma web, que es lo que se ve allá, con paneles solares en Se me fue el nombre del evento, es en Puebla, es el Smart City Expo de Puebla del 2018. Y en 2020 me tocó trabajar con uno de los príncipes. Es que en Arabia Saudita hay un montón de príncipes. Entonces, la mayoría de los príncipes son rectores o son dueños de empresas o cosas así. Entonces, uno de ellos es el rector de una de las universidades más importantes de Jeddah. No me acuerdo el nombre, que es Cake, pero todas tienen nombres, todas comienzan con K porque es el rey de tal cosa, ¿no? Entonces, así más o menos. ¿Qué es ADIM? Más o menos les comentaba, ¿no? ADIM es una startup que surgió de estos tres chicos. Es él, y creo que el tercero no sale aquí. Él es Mustafa, él es Esteban Canepa, que también está vasqueño, por cierto, y el otro es Ahmed. Es él, el de aquel lado. El primero del lado izquierdo, del lado derecho, perdón. Ellos son los tres co-founders, son doctores, no son específicamente gente del área de desarrollo de tecnología o software, sino que son investigadores. Entonces, desarrollaron el producto, imprimieron como que, ahorita estaban mostrando, ¿no? la Arduino. Ellos diseñaron la PCB, como que la prototiparon, así como lo estaban mostrando. Y lo que ellos generaron, la innovación que ellos generaron como tal, fue un sensor que tiene... Ustedes dicen, no, pues, ¿qué hay de innovación en un sensor para que les den $1 millón? Son sensores plug and play. ¿Qué quiere decir? Que son sensores que se colocan en lugares remotos donde no hay señal, donde no hay comunicaciones. Utilizan un protocolo que se llama LoRaWAN y tienen una cámara. Lo interesante es cómo le hacen, por ejemplo, el mantenimiento es una vez cada año o cada 6 meses. ¿Cómo le hacen para que un dispositivo que detecta como 40 variables del entorno, que aparte detecta objetos, detecta vehículos, detecta la parte de las inundaciones, personas, le dure tanto la batería? Pues ellos lo que diseñaron fue una cámara con una cámara infrarroja me parece que es como de 120 por 120 píxeles. Lo combinaron con una tecnología de ultrasonido y con ambas combinadas podían hacer la detección estetoscópica de lo que hay debajo del sensor. Entonces, hacían lo que hace una cámara 4K con sensores infrarrojos, pero por una fracción del costo. Entonces y aparte con un súper bajo consumo de energía. Entonces, por esa razón es que ellos ganaron ese concurso de founding. Tema interesante, ¿cuántos de aquí saben qué es una Smart City o han escuchado qué es una Smart City? Bueno, les comento yo para ahorrar. Bueno, como tal, una Smart City es una ciudad conectada directamente por dispositivos, básicamente, ¿no? O sea, una ciudad inteligente tiene sus diferentes procesos, procesos de gobierno, procesos de transporte. Una cosa, por ejemplo, que yo vi ahora que fui a Alemania es que todo el sistema de transporte está cronometrado. Entonces, tienes las horas de llegada, las horas de salida, si se retrasan, todo eso está conectado de manera muy precisa. Entonces, sabes exactamente que si te quedas en la parada, en qué momento va a llegar el camión o en qué momento se retrasa y no sales, ¿no? Entonces, eso es parte de la base de lo que es una ciudad inteligente, ¿no? Tiene que ver con infraestructura digital, sensores, inteligencia artificial, análisis de datos en tiempo real y sobre todo los servicios centrados en la ciudadanía, o sea, de que facilitar la vida a las personas que viven en una ciudad. Una cosa que tienen los árabes, que descubrí cuando estuve allá, es que esta gente pues tiene dinero de sobra y lo que ellos están haciendo es construir estas ciudades desde cero. O sea, plantean el fundamento de las ciudades, de las siguientes ciudades que van a quedar listas para el 2030, según ellos, es que todas estas ciudades estén interconectadas y básicamente los servicios básicos de transporte, recolección de basura, los servicios gubernamentales, todo eso esté conectado por medio de inteligencia artificial, sensores, servicios, y no haya personas de por medio. O sea, únicamente van a haber personas que van a proveer la parte de soporte, pero no van a haber personas realizando estas actividades, ¿no? Eso es la idea. Quién sabe si lo logren, pues es para el 2030, ya eso falta poco, pero al menos en cuestión de inversión, estamos hablando de que a ese proyecto le invirtieron $1 trillón. Entonces está un poquito así como que, bueno, tal vez si lo logran, tienen el dinero. Y bueno, tema de las Smart Cities, el fundamento de las Smart Cities es el tema que tiene que ver con IoT, Internet de las Cosas, ¿no? El Internet de las Cosas es la base de los dispositivos interconectados a la red. Estábamos hablando de los Arduinos, los Raspberry, y agréguenle internet, agréguenle sensores y ya tenemos un dispositivo de internet de las cosas, ¿no? Pero parte de esa es parte del proceso de cómo crear una solución para Smart Cities. El IoT es la base, ¿no? El sensor es la red y la placa base. Pero ¿qué pasa con la comunicación de los datos? ¿Qué pasa cuando comienzas a generar información que sea relevante a las personas, a las empresas, a lo que sea que esté conectado a ese sensor, ¿no? Entonces, esa parte es como la que yo veo que siempre se olvida cuando estamos diseñando sensores, cuando estamos diseñando dispositivos. También hay que pensar en cómo un solo dato o la recolección de un solo paquete no es tan importante como la recolección a través del tiempo de un conjunto de datos. Esa información te puede generar indicadores que te pueden servir para tomar decisiones, ¿no? Entonces hay diferentes capas en la parte de este fundamento, que es la percepción, que son los sensores, la red, cómo vas a comunicar esa data, middleware es el software, el procesamiento, todo lo que hay de por medio, y la aplicación, las interfaces, de cómo le va a llegar esa información, cómo se la vas a entregar al cliente, ¿no? Al cliente o a la empresa o lo que sea que vaya a trabajar con esa data. Entonces, hace rato más o menos les comentaba esto, el sensor SADIM es eso. Ellos, por ejemplo, el sensor SADIM tiene esta comparativa contra la cámara, ¿no? Ellos hicieron como que puedo utilizar una cámara HD, pero ya voy a perder toda la capacidad de poder colocar el sensor en una ubicación remota. Entonces, con esa patente que ellos generaron, estaban consumiendo aproximadamente esto por la misma capacidad de adquisición de datos que tienes acá. Entonces, redujeron por completo la carga de energía y ellos colocaban una batería que duraba prácticamente 6 meses al sensor y la idea era que con un panel solar se retroalimentara esa batería, entonces pudieras tener, se supone que debería durar al menos 3 años, pero el proyecto se vendió con mantenimiento cada 6 meses, o sea, para asegurar que un funcionamiento óptimo de los sensores, ¿no? Entonces, como les comentaba al principio, ellos ya tenían la patente del sensor, pero no tenían plataforma y básicamente yo fui la primera persona que contrataron para poder desarrollar esa plataforma. Ya tenían una base, no sé si algunos han escuchado hablar de Postgres. ¿Me suena? Bueno, Postgres es un módulo o un plugin para Postgres que levanta APIs de las tablas. O sea, directamente, no tienes que programarlo, simplemente lo configuras y ya tienes un endpoint de tus tablas. Entonces ya puedes hacer consultas directamente sin tirar ninguna línea de código y el endpoint lo que va a hacer es un CRUD hacia las tablas que tú quieras generar. Entonces, esa fue la primera versión que ellos tuvieron como experimento. No era lo más óptimo, pero cuando menos ya estaban generando data que les servía para sus experimentos. Cuando entro yo, pues yo venía de un entorno donde venía aprendiendo Node.js, ya venía como que un poco en el desarrollo de sistemas, ya había aprendido cómo hacer MVC. Y hay algo que pasa con Node.js que creo que la mayoría de las personas, si no me equivoco, lo agarran para frontend, se lo agarran para instalas React, creo que Next.js es una solución, sinceramente tiene rato que no agarro JavaScript, pero me parece que es una solución que puedes implementar para una solución completa, ¿no? Hacer las APIs, hacer el backend, hacer toda la parte del frontend también. Yo lo que descubrí en aquel entonces, yo trabajaba con Java, con un framework que se llama JBoss, y yo dije, tengo que encontrar algo similar a esto en Node.js, que tenga más o menos la similitud. Y lo que encontré fue un proyecto que se llama Sales.js. De hecho, sigue activo. Lo revisé esta semana y eso está genial porque la verdad, cuando yo lo comencé a implementar, tiene todo el patrón en MVC. Tú puedes colocar tus APIs, puedes colocar servicios, que eso fue algo que nos sirvió bastante a nosotros porque esta aplicación se volvió muy, muy compleja con el pasar del tiempo. Entonces, la base de la primera infraestructura que se diseñó fue Mapbox.jl para la parte de los mapas, Vue.js para la parte del frontend, la parte de los componentes visuales, y el framework como base es Sales.js, donde pusimos todas las APIs, donde pusimos toda la parte del frontend, y una cosa que se llama Waterline, que en aquel entonces era medio novedoso, porque era un solo ORM para diferentes bases de datos. Servía para MongoDB, servía para MySQL, para Postgres. Entonces dije, ya me quité un montón de pesos de encima para diseñar la infraestructura de esto, ¿no? Y todo esto se colocó, también el founding que les dieron fue, no recuerdo cuánto, pero les dieron también infraestructura de AWS. Entonces, pues utilizamos RDS y EC2 para poder publicar esta primera fase del proyecto. El proyecto básicamente hacía esto, los sensores se colocaban en una zona que tuviera algún poste o algún puente alto. Lo que pasa en Arabia Saudita, ustedes dicen, ¿por qué ponerlo en un solo punto, ¿no? en un solo lugar? A diferencia de Google Maps, por ejemplo, que te da como que la estadística de todos los teléfonos, ¿no? Lo que tienen en Arabia Saudita es que allá casi no llueve. Llueve como 10 días al año, más o menos. Entonces, ellos no tienen sistemas de, ¿cómo se dice? Hídricos. O sea, así la parte del alcantarillado de las calles carecen porque no tienen la necesidad. ¿Qué sucede cuando llueve? Y llueve de verdad. O sea, llueve poco, pero cuando llueve, llueve que se lleva casas, se lleva coches, se lleva personas. Entonces, por esa razón es que vieron importante esa solución de poder colocar en lugares donde saben que las corrientes de agua son fuertes, y la idea es colocar sistemas de alertas para que conforme vaya subiendo el agua, mandar una brigada y evacuar esa zona. Entonces, así comenzó este proyecto y ese es todo el proceso, ¿no? Llueve, se detecta la alerta, se manda por SMS una brigada, ya está todo inundado, y en qué momento ya es seguro otra vez retornar y activar otra brigada, ¿no? Bueno, lo que les comentaba, la infraestructura corría sobre AWS, teníamos un nodo de Postgres corriendo en RDS, y la solución, que era con Node.js, con Sales.js, estaba corriendo sobre EC2. Para quienes no conozcan Sales, esa es la página de cómo está estructurado Sales.js. Sales.js, lo buscan, ahí les va a salir en la página. Está la versión 1.2, si no me recuerdo. Y está todo bien documentado. Lo interesante de aquí es cómo está estructurado el framework. O sea, todo esto que ven aquí es toda la parte donde pueden colocar sus APIs, sus modelos, todo. No tienen que pensar en toda la infraestructura. O sea, al menos para una persona, para un equipo pequeño de una startup, está súper bueno porque ya todo está definido por templates, y lo único que hay que hacer es reemplazar los templates por datos que vayan a utilizar ustedes, por ejemplo, ¿no? Una cosa que nos fue muy útil es la parte de right to left, porque esta solución tenía que ser escrita en lenguaje árabe o en escritura árabe. Entonces ellos leen al revés que nosotros. Nosotros somos de izquierda a derecha, ellos son de derecha a izquierda. Y sí, esa es la estructura del framework. Así se veía la primera fase de esta solución. En tiempo real se ve la comunicación de los sensores. Cuando llega el paquete, tú podías consultar las últimas 24 horas de datos del sensor y así ver cómo qué data es la que se va acumulando en ese lugar. Bueno, pasaron varias cosas. Voy a ir un poquito rápido porque ya se está acabando el tiempo. La primera fase a la que nos enfrentamos fue que comenzamos a tener varios proyectos. Los primeros 2 años pasamos de 10 sensores de experimentación a más de 100 sensores. O sea, comenzamos a tener proyectos en diferentes partes del mundo. Se colocaron sensores en las 4 ciudades principales de Arabia Saudita, se colocaron sensores en Alicante, en España, se colocaron sensores en Canadá, se colocaron sensores en Texas. Y comenzamos primero con un número pequeño de sensores, pero que estaban enviando paquetes cada 30 segundos. Entonces, multipliquen aproximadamente de 105, 110 sensores por un paquete cada 30 segundos, con un paquete de 20, 25 variables aproximadamente, 24 horas, una semana, al año. Entonces, estamos hablando de ya en los millones de paquetes, ¿no? ¿Qué sucede? Que la comunicación en tiempo real la teníamos con HTTP, con APIs. No era eficiente ni para depurarlo, ni para hacer la comunicación. Eso no era en tiempo real, eso tardaba bastante. La primera evolución de esto fue utilizar Socket.io, que era una comunicación ya bidireccional con sockets. Y sí funcionó, la primera fase de experimentación con esto funcionó, pero el problema era que nuestra arquitectura se volvió más compleja. ¿Por qué? Porque tuvimos que crear microservicios que refinaban la data por paquete y también antes de mandarla al cliente habría que verificar que las variables eran correctas. Entonces tuvimos varios servicios intermedios que evaluaban los paquetes y al mismo tiempo servicios que se comunicaban entre ellos. Entonces no podíamos mandar directamente la data raw al cliente web. Tenía que haber un proceso de por medio que pudiera evaluar todo el mecanismo. ¿Qué fue lo que más nos sirvió? En este caso, protocolo MQTT, que es más industrial, se usa en la industria de la parte de los vehículos, por ejemplo. Internamente, todo lo que es comunicación satelital de los sensores internos de un vehículo utilizan MQTT. Y fue como que el protocolo que utilizamos para poder trabajar. Pasamos de un patrón de comunicación bidireccional entre cliente y servidor a un patrón pub-sub. Y esto nos hizo, bueno, al menos a mí personalmente me hizo cambiar por completo la visión del proyecto, porque aquí aprendí cómo funcionan los sistemas distribuidos. No nada más es la parte de la comunicación de la data de los sensores, sino que además ya podía yo implementar microservicios que se comunicaran entre ellos, la salud entre ellos y reaccionar ante estos, si había una sobrecarga de datos o un momento en el que el streaming de datos era demasiado alto, yo podía identificar la salud de ese servicio y cambiarlo por otro o levantarlo por otro o escalar ese servicio también. Utilizamos un broker. En vez de utilizar la comunicación directamente en el framework, lo extrajimos del framework y comenzamos a utilizar un broker. Si no saben el concepto de broker y están metidos y quieren meterse en el área de sensores, les recomiendo mucho que lean sobre, por ejemplo, RabbitMQ y MQX fue la versión fue el broker que nosotros usamos. ¿Por qué? Porque MQX tiene la capacidad de recibir datos, por ejemplo, en MQTT, convertirlos a WebSockets o convertirlos a gRPC. Entonces, nos servía para directamente el cliente en web, lo mejor que puedes encontrar es Socket.io. Es como WebSockets, ¿no? Es lo mejor que puedes tener en web. También está el cliente en MQTT, pero por compatibilidad nos servía bastante comunicar la data a MQTT, a los microservicios, que un microservicio evaluara, ingestara la data en la base de datos y una vez que terminara este proceso, mandar por WebSockets al cliente web. Listo, ya no nos salíamos de algo más que no fuera JavaScript prácticamente. Es un pequeño, bueno, no sé si se ve muy bien, pero es un pequeño demo de cómo se ve un cliente de MQTT corriendo con JavaScript en Node.js. Y bueno, no cometa mi error, que ahí tiene la accesorio y la contraseña, ¿verdad? ¿Qué sucede? Que para mí ocurre un cambio muy drástico, porque después de 2 años, nuestras consultas tenían un peso muy feo, de que nuestras consultas pasamos de consultas de 20, 30 segundos a consultas de 15 minutos, 20 minutos, porque toda nuestra infraestructura de datos no estaba hecha de manera correcta. La hicimos para que funcionara, mas no la optimizamos para que fuera escalada al tiempo, ¿no? Entonces, ¿ya? Ok, bueno. Sí, básicamente, pues eso es parte de la base de la infraestructura de este proyecto. Si acaso nada más finalizar un poco con... Esto fue el resultado final. Se terminó el proceso de... Migramos la mayoría de microservicios de JavaScript a Python. ¿Por qué? Porque casi todo lo que es procesamiento de data, hace unos años, ahorita actualmente creo que ya está más chido en JavaScript, pero básicamente todo lo que es data se hace con Python. Apache Spark, Pandas, Polars, todo eso está en Python. Algo interesante es que pues actualmente en JavaScript ya hay librerías que son para procesamiento de datos. Hay algunas que están como en experimentos, pero por ejemplo, una que a mí me gusta mucho, Polars, ya está en JavaScript. Y puedo utilizar data frames directamente en JavaScript. O sea que ya pueden tener toda su solución para todo el procesamiento de datos, para toda la ingesta de datos, para toda la parte de sensores, APIs, backend, todo con JavaScript. Entonces, pues, es eso de lo que les quería explicar. Gracias.
A esta charla, pero ya no tenemos tiempo. Entonces, si quieren pueden escanear el QR de César. Me parece que casi siempre estás cerca del booth de AWS, ¿verdad? por si quieren acercarse a él para hacer muchas preguntas. Estuvo muy interesante todo lo que hiciste allá en Arabia Saudita. Entonces, un fuerte aplauso y continuamos con nuestra siguiente charla. Esta está Hansel Villa, que es estudiante de último año en Ingeniería de Software con enfoque en desarrollo backend especializado en Express.js en la integración entre sistemas IoT y aplicaciones web. Ha colaborado en proyectos como un sistema de riego automatizado con sensores, un prototipo de vehículo autónomo para interiores y aplicaciones interactivas con JavaScript y microcontroladores. Y también tenemos a Fernando Villaseñor, quien es estudiante de último año de la Ingeniería de Software de la Universidad de Colima. Ha participado en proyectos como en el desarrollo de una app móvil para comunicaciones alternas mediante LoRa. Adicionalmente, es un miembro activo del programa Microsoft MLSA y promueve y tutorea a otros estudiantes en el uso de la nube, el IoT y JavaScript. Un fuerte aplauso para ellos.
Hola, hola, gracias por estar aquí. Mi nombre es Fernando, mi compañero.
¿Sí me escucha?
Sí.
Bueno, primero que nada, una disculpa. Estoy usando Linux. ¿Alguien de aquí usa Linux? Sí, ok, bien. Tuve un problemilla con el mousepad, ya me está fallando. ¿Quieres presentar?
Bueno, les vamos a hablar, como lo pueden ver, del IoT. ¿Por qué se llama así la charla? Todo hay que orientarlo al IoT. Bueno, teníamos una clase con un maestro de redes y todo lo enfocó hacia sistemas embebidos. Y él le preguntamos, maestro, ¿y por qué estamos viendo sistemas embebidos? Y nos dijo, todo hay que orientarlo al IoT.
Sí. Bueno, empezando un poco con qué es el IoT, ya me hagan un poco el favor de explicarles qué es el IoT acá mi camarada, el speaker anterior. Entonces, Fer se le rifó con esta descripción de qué es el IoT, pero principalmente a mí me gusta... Y se murió un píxel. Principalmente me gusta esas tres palabras, electrónica, software y conectividad. Creo que es una manera muy sencilla de resumir qué es el IoT con tres palabras. Y si se quieren recordar pues qué es el IoT, esas tres palabras son clave.
Bueno, aquí tienen un meme. Dice que la S en IoT significa seguridad. IoT no tiene S. Ese es el chiste. Regularmente los manufacturadores priorizan efectividad y costos antes que la seguridad, hablando de sistemas embebidos. Como pueden ver en el hotel, no sé si alguno se quedó, pero se podía ver la red de IoT, ni siquiera ocultaron el SSID, entonces pues sí hay muchas vulnerabilidades en toda esta área.
Pasando un poco sobre, antes de entrar al IoT con JavaScript, quisiera hacer como una mención honorífica a qué otras herramientas y tecnologías hay para hacer IoT. Bueno, principalmente cuando buscamos cómo empezar con el mundo del IoT, Arduino, Raspberry Pi, todo esto, lo principalmente que vamos a encontrar es con Arduino o con Arduino, con C++ y con Python, con MicroPython. La verdad es lo que Fer y yo usamos a la actualidad, es lo que tiene más comunidad, más soporte, vas a encontrar más tutoriales, más información y sí es una buena manera de empezar. Otras opciones, tal vez un poco no tan recomendadas, que yo no sabía que se podía, era con Java y con Go, que me dijo Fer hace unas semanas de que se podía, y no sé cómo todavía, pero bueno, se puede. Si quieren saber más, pregúntenle a él. Y bueno, la más importante de estas creo que es Rust. En los últimos años Rust ha ganado mucha popularidad por ser un lenguaje de programación muy seguro. Ya lo están usando en todos lados, para el front, para el back, ya no ni se diga para los sistemas embebidos. Pero sí.
Ahora, a lo que venimos todos, IoT con JavaScript. ¿Por qué decidimos darles una charla sobre el IoT con JavaScript? Es algo que no es muy común, pero programar los embebidos con IoT, programar los embebidos con JavaScript, no necesariamente consumir servicios con JavaScript. Es programar desde el firmware. Para eso tenemos frameworks como JSConf, que es parte de la OpenJS Foundation, y tenemos a Johnny5. ¿Por qué JavaScript? Porque JavaScript es el lenguaje más popular entre los developers, es el lenguaje más usado actualmente. Entonces, pues eso te da una oportunidad de llegar a más personas que se interesen. No sé si alguien de aquí tenga Alexas en su casa, focos inteligentes, pues todo eso son sistemas embebidos. Bueno, primero tenemos a Johnny5. Johnny5 es un framework enfocado a sistemas embebidos y a la robótica. Pueden ver aquí, es puro JavaScript, es JavaScript normal. Para poder usar Johnny5 necesitan un protocolo de datos precargado en su placa. Johnny5 es compatible con placas como Arduino, la Raspberry Pi y un montón más, pero esas son las más populares.
Y por alguna razón no la SP32, que fue nuestra primera opción para una demo que queremos hacer más adelante, pero bueno.
Sí. Y para poder usarla ocupan precargar firmata. No sé si alguno conozca ese protocolo, pero ajá. Bueno, a continuación está JSConf. JSConf es para programar microcontroladores. Funciona muy bien. Funciona con placas de menos de 62 kilobytes de memoria RAM y flash de 200 kilobytes. Entonces, esta es una opción mejor que Johnny5 para ciertas cosas. Por ejemplo, si quieres hacer un deep sleep de Bluetooth, un beacon, pues te serviría mejor esto, consume menos energía, es más eficiente y ocupa menos memoria, ocupa de un dispositivo más eficiente.
Un breve paréntesis que yo quiero hacer aquí es de que también cuando decidimos entrarnos al mundo de IoT con JavaScript, nuestra primera opción fue usar placas que usaban nativamente JavaScript. Desgraciadamente había una que no recuerdo el nombre, pero se las puedo investigar un ratito si me preguntan, que tú podías codificar full con JavaScript. Ya está descontinuada, ya no se puede encontrar. Había otra que se llama Spruino y esa no la podíamos encontrar aquí en México, era puro europeo. Le dije a Fer si nos rifamos con una de esas, pero era muy caro para nuestro presupuesto. Entonces, bueno, acabamos haciendo un proyecto simple con Johnny5. Pero continuando con la charla.
Bueno, aquí tengo una comparación. Entonces, ¿cuál uso? Si quieren empezar, usen Johnny5. Es compatible con Linux, es compatible con Windows, pero ocupan instalar un montón de dependencias y hacer un montón de cosas que lo complican bastante. Nosotros hicimos el proyecto en Linux porque en mi computadora no funcionó. Windows, yo uso Windows, acá mi compañero usa Linux. Pero funciona con placas populares para que después pueden adaptar a proyectos con C++, como Arduino, Raspberry Pi y corre sobre Node.js. Después tenemos a JavaScript, que, pues, como ya lo había dicho, es útil para aplicaciones más que requieren que sean efectivos en recursos, en costo, y es apto para programar microcontroladores de recursos limitados. Después tenemos otra opción que también es parte de la OpenJS Foundation. Tenemos a Node-RED, que es una herramienta de programación de flujo en bloques. Si van empezando también con la programación y con el IoT les interesa, Node-RED es una opción fácil para consumir los datos de tu sistema embebido y colocarlos en tu web. Es como el puente para tú poder consumir los datos de tus sensores. Por ejemplo, quieres saber qué temperatura hay en tu casa, lo lees y lo mandas a tu web y lo revisas desde tu celular.
Bueno, queremos enseñarles una pequeña demo que tenemos. Somos fans de Clash Royale nosotros y por eso llamamos el juego Click Clash, que de hecho queremos ver si alguien quisiera aventarse a participar. Dos voluntarios que quisieran jugar.
Por favor, dos voluntarios. No, aquí,
¿No?
uno.
Ah, camarada.
Y dos, va. ¿Quieres mostrarles un poco de cómo se ve el código antes?
Sí. Bueno, este es el index principal. Aquí tenemos... es que aquí tengo todas las impresiones que hice para manejar las... ¿Cómo se llaman? Las placas. Aquí tenemos más que nada sobre ya la jugabilidad. Que de hecho les puedo compartir el repo, que no lo puse en las diapositivas, pero si a alguien interesa se lo puedo dar sin problemas para que lo pueda checar.
Bueno, el juego consta... ¿Sí pueden pasar, por favor? Tenemos dos Arduinos Nanos. Lo hicimos en una Arduino Nano porque pues, es más chiquita y se puede mover más fácil. Es un clicker. Van a hacer una competencia y les vamos a dar un premio. No lo dije, pero...
El juego consiste en ver quién hace clic más rápido. No sé si se ve. Aquí está la cantidad de clics que tienen que dar para ganar.
No se nota, pero dice 100.
100. El primero que llega a 100 clics gana.
Lo pueden mover si gustan, lo pueden agarrar con un cable. Tiene 2 metros de distancia.
¿Aquí dónde está? Ahí va.
¿Quién creen que va a ganar? Rojo. Va rojo
Bueno, y
ganando.
no les dije, pero todo esto usamos WebSockets para hacerlo en tiempo real y es el poder pues de combinar el IoT con JavaScript. Ya ganaron.
Sí. Muchas gracias. Un aplauso para nuestra concursante. Ahorita les damos un premio. Bueno, y también, ¿por qué usar JavaScript en el IoT? Bueno, te da la ventaja de tener todo tu aplicación en JavaScript, desde la programación de tus microcontroladores hasta tu frontend, tu API, tu backend, tu base de datos, todo, hacerlo en JavaScript. Es la facilidad de tener un solo lenguaje, diferentes frameworks, sí, pero es la consistencia de hacerlo todo en un mismo lenguaje, se facilita, es más rápido hacer incrementos, no tienes que aprender un lenguaje nuevo y después pues podrían seguir indagando en el mundo de los embebidos.
Ya para acabar, yo quiero hacer un breve comercial. ¿Alguien ubica a ese señor?
Hashtag ad, Don Chambitas.
Okay. Con él y un equipo estamos formando una aplicación que se llama Open Chambas, que en sí es para tanto personas que buscan chambas como para las que lo ofrece. No sé qué tanto puedo decir porque firmé un acuerdo de confidencialidad y es la primera vez que firmo uno. Pero lo que puedo decir es de que puedes encontrar chambas, ofrecer chambas y también subir tus eventos y ver qué eventos hay en tu zona cercana. Si quieren saber más, síganlo en las redes que tiene. Y también ya para acabar en las nuestras, ¿algo más? Sería todo.
Sería todo.
Para esta charla, como era una Lightning Talk, tampoco tenemos espacio de preguntas en este momento, pero pueden acercarse a ellos en el área de networking para preguntarle más acerca de su proyecto. Entonces, nuevamente un fuerte aplauso para Fer y para Hansel. por venir a nuestra charla. Ahora va a comenzar What? AI has access to my node environment from MCP to agents. Esta charla es presentada por Shibai Lamba, desarrollador de experiencia de ingenieros en Couchbase. Shibai es desarrollador de software con experiencia en DevOps, Machine Learning y Full Stack. Entusiasta de código abierto. Fue mentor en Google Coding y Google Summer of Code y MLH Fellow. Es muy activo en comunidades TensorFlow.js, OpenMinded, CNCF, Soda Foundation y ha dado charlas en conferencias como GitHub Satellite. Un fuerte aplauso para Shibai.
Gracias. And I'll try my level best to give my introduction in Spanish, so please, if I say something incorrectly, bear with me. Hola, soy Shibai. Estoy muy emocionado de presentar mi ponencia en JSConf México. Gracias. Now, of course, before I officially begin my presentation, can anyone share what is the biggest festival that we are celebrating tomorrow? Day of the Dead. So I made a fun thing before I even begin, which I like to show to everyone. So here, you can see, I'll probably drop back a bit. There's a fun little demo that I wanted to show you. And the reason for this is that my talk is about AI, but this is basically AI in the browser. And the fun thing is that it's basically using a model from 2020 called as TensorFlow.js. And within that, it has a model called as BlazePose. So the idea is that with this model, the model can track the different parts of your body. It knows where my hand is, where my arm is, and that is why if I rotate my arm, if I rotate my, everything else, it knows where exactly each and every part of my body is. And this is thanks to this pose estimation. So one of the use cases for this was during COVID, where you didn't have the capability to exercise outside. So you could basically exercise inside of your home, and you could track whether the posture of your exercise is correct or not. So there are a lot of startups that were basically using the webcam, and they were tracking your exercise movements, and they were able to tell you whether you're doing this accurately or not. So the reason I wanted to show this is, of course, we are in Mexico, and we are, of course, right on the Day of the Dead, and it's a massively celebrated holiday. And also, of course, this can also be applied to the US and the Western world, where everyone is celebrating Halloween. So I just wanted to put up a spin on this. Of course, my talk is not about how you can run AI on the browser, but I am a huge advocate for that, and I'd be more than happy to have conversations with you around TensorFlow, around how you can build AI on the browser. But we are today speaking more about Node.js. So my talk is about, as much as I want to speak about machine learning on the browser, on the front end, my talk is more about Node.js. So without further ado, I'll quickly also a quick I have as a developer experience engineer at Couchbase. I'm leading Couchbase. I'm also you are interested to speak about Docker and DevOps, more than happy to speak about it. And now, so if you connect with number, I was unique as first of ChatGPT back in 2022, when it was simply a text answering machine. So you would ask it a question, hey, tell me what is the formula to calculate the speed of sound, or maybe the speed of light, and it would just give you the response. But today, if you look at the current landscape, whether you talk about Gemini or even open source models like Gemma, right, they have the capability of not just doing text generation. Today, you can give them a multimodal input. Maybe some of you might have looked at a talk from Thomas about how you can do in-browser capabilities of like doing multimodal capabilities right inside of your Chrome. So whether you are trying to generate an Ghibli-style image with the help of ChatGPT, or you're trying to do some research or deep work, today like LLMs are a lot more capable. But the reason that they're capable today of being able to handle all of this is thanks to something called as tool calling or function calling. So the idea is that most of the LLMs are based on a transformers architecture. And the way that they basically take any kind of input from a human, whether it's a text input or it's an image, is that they're being converted into these input tokens. And then the tokens are being understood by these complex transformer algorithms. And then you get a bunch of output tokens, which are then represented to the person. So of course, they still don't have, or they lack the capability of being able to like do as simple as a database call or an API call. And the way that they do is with the help of the MCP, right? Or with the help of tool calls, where basically the LLM is able to understand, okay, it should make this API call, and then it offloads that capability to the actual application itself, and the application gets the functions that, hey, I should call this function with these inputs. Then the application executes the function, returns the JSON response back to the LLM, and the LLM uses that for further processing. So that's how generally the tool call basically works. And that's how we were able to get functionalities within ChatGPT like, okay, tell me the current weather. Or like, let's say, do a real-time web search and give me some results, in order to be able to remove the hallucination problem that generally these LLMs had because they were trained up to a certain cutoff period. So if you ask them any question after that cutoff period, it would just hallucinate. So we started to see more and more of these tool calls and get much more relevant results. And that basically gets us to the context of Model Context Protocol. So this as a protocol was launched by Anthropic last year in November. And the idea was very straightforward, that if you want to extend the capability of LLMs beyond just text generation, but also be able to do real-time analysis, connect to a database, connect to a real-time API, we can do that with the help of the MCP protocol. So here, whether you have an LLM from Anthropic, from OpenAI, from Google, or an open source model from Meta, right? All of them can basically communicate with the help of this open source or an open standard protocol with the help of Model Context Protocol. And now your LLMs have access to RESTful APIs, whether it's like the Google Drive API, or it can connect directly with apps. So maybe you're having Salesforce data in your company and you want the LLM model to be able to directly get in touch with the Salesforce data to understand, okay, what were the total number of leads that my sales team got in this year? Now you don't have to write custom operations or custom functions. You can directly use them. Or you could also interact with storage. So MCP really unlocks the capabilities for you to build applications, and that's we are truly seeing as a revolution today. So here is a general MCP interaction flow. Now, this might seem very convoluted or complicated. I'll try my level best to explain what's basically going on here. So right at the top left corner is the LLM. LLM is very basic. The user interacts with the LLM, and rest of the magic is handling with the help of MCP. So right at the top left corner, we have LLM. The user asks a question to the LLM. Now, the LLM basically sends it to this MCP client. So this MCP client is basically an app. It could be a Claude desktop app. It could be an AI agent. It could also be Cursor. A lot of us love using Cursor. I think there is a Cursor dev hackathon here led by Eileen from the Mexico, the Cursor hack. So a lot of people are using Cursor, VS Code, all of these different, different kind of extensions with which you can write or vibe code, right? You could vibe code with these tools. So all of them can also act as your MCP clients. And the idea is very simple, that you'll basically have this MCP server, and this MCP server can basically have access to a bunch of different MCP tools. So the idea is that as soon as the user will make a request to the LLM will basically have access to one or more than one different MCP servers. Now, each and every MCP server has basically a description as well, that what it's supposed to do. So maybe an MCP server is there for making a search tool. So maybe a Google search. So there is a MCP server just dedicated for doing a Google search. But there could be multiple tools within that MCP server. So there could be a tool just for doing a Google search. There might be some other tool as well. And each and every tool has a tool description. So the idea is that as soon as you as the user ask something to the LLM basically routes, okay, based on the context of the user's question, which particular MCP server should I connect with? right? So maybe if the user is asking me that, tell me when does JSConf Mexico 2027 or 2026 occur? So probably I need to make a Google search call. So it will identify, okay, I have to use the MCP server for search, and then it will probably have access to 4 or 5 different kind of tools. And these tools are nothing but just functions, right? These are functions to execute something. So there is a function to actually execute, to return me basically the list of when the actual JSConf Mexico is taking place. Or maybe there's some other tool that could save some data for you in the database. So this way, you could have a bunch of different MCP servers. Each one of them have a bunch of different tools or MCP tools. And the LLM basically decides based on what is the most appropriate tool that I should invoke for this particular input given by the user, it will do that. And the way that it does is that every single tool has a description. So it understands the description and compares it with the input given by the user or the invocation, or so basically, like, let's say it could be an MCP server for a database. So maybe I'm asking that I want to look up the top 5 records in my database. Then it would basically call the MCP server for that database, and it would basically call a tool that lets me run a SQL query to return me the top 5 results. So it's all nothing very new. It's all about how we are basically making these communications thanks to the MCP protocol. So if there are any questions, please do let me know at the end of the session. Would love to take them up. But that's the simple interaction flow, which enables LLMs to go a lot further than being able to just make tool calls. And here is a really simple example of an MCP. So we are basically using the official SDK from, or the JavaScript SDK from the Anthropic Model Context Protocol. And we are saying that this is a new MCP server. I've given it a name. I've given it the version name and a description. And this is the tool that I have created. So here I'm basically adding 2 different numbers, and it returns me the result of that. So very simple. You define a server. You define the set of tools that are going to be in that server. And then you can invoke this server with the help of any MCP client that you may choose to use. So the reason of, okay, why should I care to build a Node.js MCP server, right? So we'll basically cover that. So the idea is that we know that AI can generate code for us very quickly. But today, if you look at a lot of these different tools like Gemini CLI, Claude Code, they all are capable of being able to then run this code in a completely unauthorized manner in your laptop or in your system. And there are a lot of negative consequences if you don't do this correctly, or if you're just vibe coding without even understanding what the code is trying to do. Because it could somehow impact, like, let's say you accidentally delete a root level directory, and now you have basically bricked your entire laptop. It is possible, right? If you give the wrong prompt, and if you give because a lot of these Claude Code, they have this YOLO mode. YOLO mode basically means that the LLM will not even ask you before doing certain action, and it will just go ahead and run some unsecure code. So imagine that if you try to do this in a compliance-centric company where you're dealing with a lot of proprietary data, right? If you accidentally do something like this, it's a big, big loss for the company. Potentially billions of dollars lost because of running some unoptimized code, right? So we want to be able to use AI to write code for us and also execute it in a more secure manner. And that's what the main part of my presentation is all about. At the same time, you also want to use the huge JavaScript ecosystem because we have more than 3.1 million packages available to us. So how do we use that capability of securing the code that the LLM is generating and also use the large ecosystem of JavaScript? So that's what we'll basically look at. And I want to quickly show you one example of MCP. So here I basically have Docker, and I'm not sure if it is clearly visible for all of you, but basically I have an MCP server of the company where I work. It's a database company. So basically what I'm doing here is, let me go to the NPM here, and I'm just going to run this agent. So I'm basically running an AI agent, and I can ask it a question like, tell me what buckets I have in my database. So maybe like I just want to understand what all buckets do I have in my database. And I run this. and it gives me a prompt. Hey, I want to basically call this particular tool. So the idea of what's happening here is that I'm interacting with this agent, and this agent I'm using something called as an open source agent framework from Docker called as C agent. And here I basically created a simple function where I say that based on the user's prompt, I'm going to use this couch-based MCP server, which is a MCP server for a database. And if you're interested, like it has all of these different tools. So it has tools related to being able to delete documents, being able to add documents, being able to run a SQL query. So here I said, okay, tell me what all buckets I have in my database. So it used this particular tool called as get buckets, right? So get buckets in cluster. So depending on the user's prompt, the LLM was automatically able to route to the appropriate tool from the MCP server, just based on the description of the tool. So when you define an MCP server, you define the functions and the description based on which the LLM decides which particular tool to call. So here I say yes. So I'll just zoom out a bit and I'll say Y. So I just press Y and it tells me, hey, these are the list of all of the different buckets that I have in my database. So here I didn't have to like necessarily write a function myself in JavaScript or in TypeScript, and I could just use the AI to help me. So that's like a quick idea of how MCP is a really cool thing to work with, right? So now we'll move on to like, okay, how can I run software code securely thanks to the code that is being generated with the help of LLMs? So this is where I'll introduce you to basically the MCP node code sandbox. So this is an MCP server which is very popular. There are more than 50,000 downloads in less than 3 months. And the entire idea is, as it says, node code sandbox. So it basically creates a sandbox where you can securely run Node.js code with the help of MCP. So imagine that your LLM generates some Node.js code and you want it to be run securely. So it basically is capable of doing that. Now, how does that do that, or what's the approach of doing that? I'll cover that shortly. So the flow is very simple. The LLM writes code for you. The code is sent to the MCP server. And now you want the MCP server to somehow run this code safely with the help of Node.js. So what is the question mark? Like, how do we accomplish this, right? And now this output of the code is basically sent back to the LLM. So the idea is that now you can run this particular code securely in a sandboxed environment so that you're not exposing this LLM generated code to external world where it could mess up your laptop or it could mess up your dev environment. So the answer to that is we'll eventually build to it. So, there are multiple options for us to run LLM code with Node.js. You could have like a VM module, or you could have a child process, but that means that you're basically executing some untrusted code in the user space, which is not going to be safe. Or you could try to run your LLM generated code in some micro VMs or some kind of an edge runtime. But again, that's probably making it a lot more complex, right? Why to set up a new VM just to run some LLM generated code which could probably just be incorrect? So the solution to that is Docker container, right? So you could basically run Docker container and it acts as a sweet spot for you to run this LLM generated code because you are still running this code in a containerized environment, which means that the container still has access to your external volumes. So you could basically read and write into files and have complete secure access because you have access to your own VM processes that are taking place in a containerized environment. So the idea is that simple. The LLM will write the code. The code is sent to the MCP server. Now this MCP server will basically spawn up, or it will spin up a new Docker container with a base Node.js Alpine image. And then the code is basically copied into the Docker container and executed with the help of Node.js. And the output is sent back to the LLM. So this way, not only I am now able to securely run my source code very efficiently with the help of this entire example, but I'm doing it securely as well. And I'm not have to worry about someone attacking my Docker container unless you're dealing with like container security. So typically you can use or build your MCP servers with the help of the official SDKs as well. So there are support for TypeScript, Python, Golang. Since we are in JSConf, I'll focus on TypeScript. And here's like a simple example of how you could build such an example with the help of the official TypeScript SDK from the MCP. So here you can see that I'm saying I want to create a new server with Node.js code sandbox. And the tool is, I want to be able to run this JavaScript code or my ephemeral JavaScript code. So here I'm saying that the output would be to run JS ephemeral and give me the processed output that I'm getting. And here we'll eventually go into the nitty-gritties of like how it works by seeing the specific import that you're making here, which is run JS ephemeral. That's the sandboxed code that we are actually running inside of our Dockerized environment, thanks to that container being spun up by our MCP server. And running this code is fairly straightforward. So on the left-hand side, you can basically see what's going on. So the MCP server, as I mentioned, will basically spin up a Docker container. The code is copied to the Docker container and executed. And this is what we are basically doing. So here you can see that we basically run this Docker exec command. So we do a Docker run. We say we are going to be using the Node LTS Slim version, and then we also pass the source code generated from the LLM inside of our Docker container that will be using it. And then what we do is that you can see in the second part of the code, we are basically creating a small copy of the code. So we create a small temporary directory, and we basically paste it inside of our Docker container as well. And then we can do a Docker exec, which will actually go ahead and execute that code for us. And at the end, you can basically clean it up. Now once you have executed the code, you don't have anything to do with it, and you are now just left with the final output that you can get. That's as simple as that. And of course, because we are dealing with LLMs, so your prompt engineering techniques are still relevant enough for you to run them with this kind of code. So basically, if you want to tweak the output and how it behaves, you can use prompt engineering techniques with MCP as well. So let's talk about adding some additional features to this before we finally disperse for a quick demo that I'd like to showcase. So if you want to install dependencies, because like let's say you want the the Node code to not just like do some simple stuff, but maybe like generate a QR code for you. So the LLM can also define which set of NPM modules I would want to download, thanks to being able to do this directly in this Dockerized environment. So the package.json will be written in the file system in your Docker container. It will install those NPM modules in your container, and then the code will basically run. Of course, there will be a latency getting improved because you'll have to install the dependencies, so that's something to keep in mind. But there are workarounds where you could basically use a pre-select image, Docker image with specific NPM modules already pre-installed. So you could cache those dependencies and use them. And the most importantly, you could also add support for being able to work with input or even output files. So for example, you could support input files where you have some working directory, and now you can mount them thanks to external volumes in Docker. And then the Node.js script can basically read and write to the same directory. So as soon as the MCP is done executing the code in this Docker environment, you can save those particular files in that output directory, and that output directory is now accessible to the user. And I'll just quickly show you that in action with the Claude code. And you can also have support for images. If you want to generate images, you want to do file references, you can also do that. And the way that is implemented is we compare the snapshots from two different Docker images and get the result. So here is like what the LLM output would basically look like. That, hey, I've created this file, I've also created a QR code, and you can see the links being generated. And this is basically the MCP output. So you can see the type text, and then you have the type resource because you have been able to generate an image, and you can see the URL encoded version of that image. And you could also technically go even more advanced and generate full-scale charts. So if you're using like some kind of chart.js library, you could ask the code for it to generate charts for you. And here's like what you could do. So you could essentially run Playwright inside of that, and you'll have basically a Node.js environment. You have a Playwright image that can do browser automation for you, and it would come with some pre-configured images from Playwright, and it could generate some charts as well. So you could go as complex as like doing all of these automations, again running this unsecure code in a completely secure environment, and do things like generating output, not just like executing code, but generating charts, running Playwright scripts. All of that can be done, again, thanks to Node.js capability. And before I jump into this, I know we are running out of time, so I'll just quickly show you a demo of this. So here I have, oh yeah, this one is cool, right? Okay, so I'll just take this one single prompt and I will rerun this. So I'll go ahead and maybe stop this and run a new chat. So hope everything works. So what I'm saying is use Node.js and use the marked package to convert the following markdown into HTML and convert that into a website, right? So here you can see I'm saying welcome to my page, and I want to eventually convert this into a HTML. And here you can see that I have the bunch of all of the different tools that I'm going to be using. So this is my JS sandbox. So these tools are coming from the MCP server. And now I'll ask it to run this. So let's see what goes on behind the scenes. So hopefully if everything works, what we are going to be seeing is that it will basically now call that JS, yeah, so it's running this JavaScript code. So it generated the code here, and it will basically run this ephemeral JS code. So this is the code generated by the LLM, but it will now run this in a sandbox environment in a Docker container that will spin up. So if I go to my Docker desktop, to my containers, I should see that actually showing up. So you can see that maybe like because it already spun up and it also like spun down. So because it it executes this so quickly that it basically now sees that okay, it has already gone ahead and created this actual HTML file for me, right? So maybe if I go and take a look at this, okay, so it did not find. Maybe because it's trying to find it in the downloads into this file. Maybe if I go to the correct place, because I know Cursor had given me the actual output, because I think there's some issue with the path. So the actual path is here. So if I go to this particular path, it should be the correct path. So if I go here, if I go, and you can see that that same markdown was converted into HTML, and I didn't have to worry about having to run this code in a separate Node.js environment. I could do all of that thanks to the power of MCP. And I can also, like, of course, visualize this, and you can see that this is a dedicated file. So of course, what I'm doing is I'm exposing my Node.js environment to this Docker volume, and I'm being able to like then store the output in an actual physical file that now I can interact in the real world but I don't have to interact with that untrusted code, because there are so many things related to MCP security that you have to be aware of. There are a lot of horror stories, like supply chain horror stories, that I will recommend everyone to take a look at. There is a dedicated Docker blog post just around this, because so many companies are trying to use MCP, but these days, like for example, the MCP protocol just recently announced support for OAuth 2.1. So how we can authorize and secure our MCP servers, right? Because till now, people could run completely unsecure code, give access to the MCP servers to your private data in your databases, and that led to so many supply chain security attacks happening. So if you're a company, like if your company is implementing MCP, do ensure that you use proper security in your MCP server with proper MCP authorization. That's something that you should do. I'm doing a lot of work in this space, and if you are having some doubts, you can ask me. But with that, I'll conclude my talk. If you have any questions related to how all of this fun stuff was basically handling. So there is an open source repository for this particular tool that I just showed you. So you can connect with me if you are interested. It's called, so I showed you basically I'll just take like one last minute, which was basically the container image that I showed to you was basically, I'll just quickly show again. It's Docker Hub. You can go to Docker Hub and Node code sandbox. You'll also find the open source code.
Casi comenzamos con la charla de Bri. Si quieren irse pasando más hacia adelante, también estaría mejor para que estemos un poco más cerca todos.
at Atlassian now.
Ah, okay.
I switched companies.
So, I'm going to talk in Spanish for your introduction. Bri es ingeniera de software frontend convertida en developer advocate. Se enfoca en hacer la tecnología más accesible, creando contenido técnico para que los desarrolladores construyan de forma autónoma. En su tiempo libre juega videojuegos, hornea o viaja a destinos mágicos. Un fuerte aplauso para Bri.
Thank you, everyone. I'm so excited to be here. Please forgive my voice. I've been doing a lot of talking, a lot of laughing, a lot of giggling, all the things. So now my voice is on its way out, so I apologize. But I'm Bree. I'm a developer advocate at Atlassian now, and I'm so excited to be here in Guadalajara for the very first time. And I just love all the hospitality that everybody has had so far. So before I yap for a little bit too long, welcome to the developer skill tree growing beyond the code. So I think for a lot of us, when we first start out our careers, mastering programming feels like our golden ticket. We work really, really hard to master syntax. We get really good at our tools. We start to ship out a lot of good features. And while that's enough to level you up until a certain point, maybe you get fewer comments on your pull requests and things like that, or maybe you even become the go-to person for a part of your code base. But eventually you might notice that that's not any longer enough to get you a promotion to senior staff, all of those plus levels. So at some point as engineers, we kind of start to hit a plateau. And it's not because we're not good at our jobs. It's not because we don't know how to code. In fact, it's really because we're actually very good at our jobs. But the skills that get us to mid-level engineer are different than the tools that are going to get us to senior staff in those higher level roles. So our problem actually starts to shift. It becomes less about the code itself and more about the ideas that we have, how we solicit them, and how we get other people to care about what we want to do in terms of work. So here's the thing. The path forward is not always a clear and cut and dry one. For everybody's company, do you feel like you have a clear path or a direction from maybe your manager about how you get promoted? Does anybody have that? I think it's kind of ambiguous a little bit, like they give you ambiguous, oh, we want you to do certain projects on your own or have certain levels of autonomy, but they don't really tell you what that actually looks like. So that's what we're going to talk about today. So what we're going to talk about is 3 different ways that we can go beyond the code and help us be a little bit more advanced when it comes to getting to those later parts of our career. So the first one is going to be talking about persuasion and about influence. Then we're going to get into building expertise beyond the code itself. And then finally, we're going to talk about how to actually future-proof yourself, which can be a little bit tricky in this career. So what we're going to talk about today, I'm hoping, is to be able to provide concrete steps to what can be very, very abstract typically. So let's get started with persuasion and influence. One of the very hard truths that we have to face is in the later portions of your career, influence is your currency. So you can be the most technically skilled engineer, you can be a 10x engineer who's rolling out stuff all the time, but if you can't get people to rally behind your ideas and really care about the work that you want to do, or go beyond your impact as an individual and start impacting full teams, full organizations, or your company, you may not get as far. So one of the pieces of feedback that I used to get all the time is that I didn't speak up a lot in meetings. And I was really confused by this, but I realized I'm really good at contributing to conversations. But what they really wanted me to do was be the pioneer and to start leading those conversations. Now, typically, I am a little bit more of a quiet, kind of a more reserved person. I like to listen and then make my judgment and sort of input myself there because I don't ever want to feel like I'm talking over people. What they were looking for me to do is to take charge, have those opinions, hold them loosely at times when needed, but to be the person to actually start the conversation. So why does this happen? Why do we have good ideas, but we have a little bit of trouble getting them in front of people? Well, there's a couple of different things. The first one is that a lot of times as engineers, we optimize for correctness. We optimize for the things that you can count on and for the things that you can measure. That doesn't take into account that the people that we're talking to as we get a little bit further in our careers aren't people who care about the code necessarily. We're talking to product managers, we're talking to designers, we're talking to organization leaders. They don't care about the implementation. They care about what the outcome is. And the other thing is, we oftentimes are not really taught or mentored on how to create influence. So how do we fix this? The first thing is going to be speaking in terms of outcomes and impact. Like I just said, when you're talking to folks at your company, maybe organization leaders or leaders who are going to be a lot farther removed from the code, they don't care about the exact implementation of your code itself. What they care about is what the code, how long is it going to take? So a lot of times, instead of saying things like, hey boss, I want to refactor this authentication, we have to switch that up and say, hey, I want to reduce incident times by 30%. I want to close this many more tickets. I want to have a measurable quantitative impact on our company, and I'm going to do that by refactoring authentication. That verbiage and how we communicate that matters to get people rallying behind our ideas. The next thing that we want to do is make this sticky. We want whatever we say or whatever our goal is to really resonate with folks. And for me, something that's been really useful is the why this, why now. We always want to talk about what pain point we're addressing directly, whether it's a pain point internally with your engineers, whether it's a pain point with your customers, and then we want to add a quantitative amount on exactly what is going to change once we fix a certain thing. So this goes from having a really big list of tech debt to people prioritizing your tech debt and wanting you to have the space, time, and capacity to work on them because it's going to have a positive, measurable impact on your engineers internally or on your customers. So influence also isn't just about the message itself, it's also a lot about trust. Do any of us have like a friend where maybe they text you every now and again, but usually it's for money? So when you see that they're like popping up in your phone, you're like, oh gosh, they're not calling to just see how I am, they want a couple of extra dollars. We have to take that same philosophy into our internal organizations as well. A lot of times we don't often socialize with people who may not be in our exact disciplines, like product managers, designers, different teams, organizations, until we want something. And we need to build those relationships beforehand to make sure that we understand what their work is, what do priorities look like in their world, and build that relationship to a point where when we do come and we want something, they don't have that, oh God, they just need something, kind of like attitude. The next thing that we want to do is we want to optimize where we can by mapping out who is going to be able to approve the decisions that we have. So who gets to decide whether we do or don't complete a project, who gets to influence and who blocks. Understanding exactly who these people are is so important. And if you have the ability, it would be excellent to put like a one-page brief together of what your ideas are, send it to them beforehand and just say, hey, this is what I'm thinking about, here's my goal, I would like to include you in some way. What would make it easier for you to say yes? Do you have any immediate concerns? That way you can bake in what those concerns are or have those conversations before you get to that large meeting where you want the decision to be made and you run a better time of getting a yes or even a maybe versus just a flat out no. And the next thing that we want to do is, instead of just bringing one big grand plan when we have ideas, we want to give them a couple of different options. So maybe one option is like a 2-week effort with a 60% benefit of what we're trying to go for. Maybe one option is a 6-week effort, but we get 90% of the way there. And then another option is that we do nothing, but we tell them exactly what it's going to cost for us to do nothing. That way it's not a yes or a no, and we can start to weigh the pros and the cons of each individual option, which again moves you away from a single static no and moves you in the direction of, hey, I can't wait 6 weeks, but maybe I can do something in 2 weeks and we can at least get part of the way there and get the ball rolling. And then once you've built credibility, you also have the opportunity now to create and craft a narrative around exactly what you would like to do. So the thing is, people do make decisions based on data. They want to see the hard facts. They want to know the numbers. But what people really remember is a story. People remember a narrative. So if you can get really good at crafting a narrative around what you're trying to do, the holidays are coming up. Shopping carts, e-commerce, all of those different companies who do that kind of stuff, they don't want a story that says that they lost 50% of their users because whether it was latency or they didn't scale appropriately. You want to have a good story. You want to be able to say, hey, we need to invest in improving our architecture because the holiday time is coming up and we want that 50% extra boost in sales. So consider two different engineers. We have Alex and we have Sam, and they both spot the same problem. Maybe it is a really inconsistent API design. Alex documents their concerns. They create like a one-page or a dense 10-page document spec. They share it out in a Slack group, but their work is really quietly ignored because they didn't put a lot of effort behind it. Then on the other hand, we have Sam, who also notices the wildly inconsistent API design, and instead of just creating a really dense 10-page spec, what they do is go through the steps that we talked about a little bit earlier. They understand who the influencers are in their decision. They create a one-pager. They meet with them beforehand. They use different language to make sure that they're speaking in outcomes and impact. And when it comes to decision time, Sam's is the one that's taken. Not because one of them is a better engineer than the other one, not because one spent a lot more time than the other one, but one put a little bit more time and energy to helping other people understand why the project was important versus just creating the document itself. So influence is not something that arrives with promotion. And I think that's something that is a really hard thing for us to rally around. Sometimes we think, okay, we're a senior engineer now. Everybody should just automatically listen to me. They should want to know exactly what I'm thinking because you have that title. It's something that cascades and something that you have to start working on right now. So it is something that you can work on right now. Maybe it's something where you pick one idea, you write a little one-page document, and then you have a couple of conversations and see if you can secure a very small yes. It doesn't have to be something big, but it builds relationships and it gets that momentum going. So once you land there, the next ceiling that you may hit is scope. If your respective edges sort of stop when it comes to your repo or the repos that your team owns, you may find that you're going to hit another ceiling really, really fast. So here's the thing. For most of us as developers, we are focused on code. Like that is our thing, that is what we tend to focus on, that's what we spend a lot of time on. But if we only focus on shipping code, we can miss a lot of the deeper levels that can help you grow your career even beyond influence itself. So the truth is the best engineers are not just good coders, they are also very good connectors. They know where their people live or the connections live within teams that aren't just your own. They know exactly how to measure up their work with strategic organization goals. So as engineers, we can be siloed, right? I think a lot of us would call ourselves maybe a front-end engineer or a React engineer. We put a lot of labels on ourselves, and the thing is, a lot of times we're incentivized to do this because we're getting work out as fast as we can, and a lot of times that's what our company really, really cares about. But we have to stop thinking about just the code itself and maybe start thinking about more high-level organization structure. What does your code look like inside of the product itself? Who are your actual customers and how are they interacting? What problems do they have? Do you understand like what your customer personas are? And I will be the first person to say for a very long time as an engineer, I wasn't aware who my customers were. I was just doing the code, I was doing the features, but once you start to think about who they are and what problems they have, it helps you really build a lot more empathy. And empathy helps us to make better decisions as engineers. So, my first thing, and I've been really loving this recently, is the mindset shift of becoming a T-shaped engineer. Now, this isn't a concrete thing, more of a mindset shift. This is where we have our expertise, which is our depth. That's going to be the long part of our T. That's going to be our technical knowledge, our debugging skills, all of those really, really technical bits. And then we have our high level or our breadth. And this is going to be where we start to collaborate or add in other pieces of the stack or the community to help us be better collaborators. So it's not necessarily a cage, it's more of an anchor to tie you to where you are, but also help you to collaborate with other folks as well. So you don't need to go buy a new course or do anything crazy like that. A lot of times this can start really simple where you shadow other teams inside of your organization, and maybe you sit in on something like a design review or a design crit to really understand like how their team works. What does success look like in their world? What are things that they're talking about? That way, the next time you get a feature, you can start having more intelligent conversations and be a part of that pioneering task as well. So the next thing that we can do is also lean into product thinking itself. A lot of times we say, what ticket am I working on? But if we can swap that for a simple, like, what problem am I actually solving? That's gonna take you a lot farther. I spoke a few seconds ago about being able to build empathy and really understand what our users are doing. And at first, especially starting a new job, I used to think, oh my goodness, we're taking so long. They're telling me all about our customers. I don't work with our customers. I work on the back end. Why do I need to know? This is why, so we can see exactly how the products that we're using affect all of our different customers. Things like accessibility, making sure that our applications are accessible for all different kinds of folks. And as a better partner, you also get better at co-writing specs. So I think a lot of times also as engineers, we kind of just wait for our Jira ticket to come on down. We don't really necessarily think about what features we're creating. But as you get to senior staff, principal, engineer, you're going to be the person who is writing those specs. So getting in the habit now of not just waiting for something to come down the pipeline for you to implement, being the person who is co-writing, who's curious, who's asking the different questions about choices, about how it's going to affect your customers, how it's going to affect you internally. Those are the things that you need in order to be able to create those specs. And then also raising your business impact awareness. Now, one of the most handy things that I have done over the past couple of years is being able to align myself with at least one strategic goal that my organization has. And every organization has them, whether it is retention or NPS scores or burning down tickets or having like a certain level of open tickets that you have. Every company is going to have like a North Star metric or a group of them. And if you can tie your work to one of those North Star goals, you are putting yourself in a way better position to have your ideas adopted internally as well. And then finally, we want to scale through mentorship and knowledge sharing. This is one of the biggest parts about becoming a more senior engineer beyond code itself. As a junior engineer, I'm sure we can all think of at least one person who was instrumental in our growth and allowed us to grow or mentored us, or maybe they just answered our questions whenever we needed. It's time for us as we grow in our careers to be that person for other people. And it's not just synchronously. A lot of times it can be creating different artifacts or knowledge sharing in the way of, hey, I found this thing, I'm gonna create a really short Loom video, I'm gonna tell you exactly how I did it, or a code walkthrough. It doesn't have to be a really big production or anything like that. It can literally just be, hey, I saw this thing, I spent 15 minutes trying to figure it out, I'm gonna write this up so that you don't also have to spend the same 15 minutes figuring it out. And then what you realize is, as you continue to adopt this process, you have a whole library of information that's not just helping other people who are gonna come to your team or junior engineers, you're helping you for the future. Because I don't know about you, but I can code something today, and me in 2 weeks will be like, I didn't do that. I don't know who did that, even though it was actually me. So we have Alex and Sam again. This time, Alex is our reliable person. They do the developer thing. They ship the tickets. They hit the deadlines. However, their work is seen as being in a black box because they don't really operate with other folks. They kind of just do their own thing on their own island. So when career opportunities or cross-functional opportunities come about, they are not necessarily the first person who is thought about. Now, on the other hand, we have Sam, who is still a reliable engineer, but they operate a little bit differently. Maybe they are more outwardly cross-functional and they attend some different cross-functional meetings, or they are more vocal in product meetings where maybe we turn those on and we just kind of sit in the background on Zoom in our pajamas and those are just like on, but maybe they try to be a little bit more vocal or at least add one or two pieces in there. That way, when cross-functional opportunities come about, Sam is likely going to be the person that gets the opportunity, not because, again, one engineer is better than the other, but one is a lot more communicative and people see and understand how they work. So, has anybody felt whiplash lately with all of the new things, whether it's a new JavaScript framework, AI, all the new things that are coming down the pipeline all the time? I definitely have, and I know it's not just me. There's so many things for us to figure out these days as engineers, and it just feels like a water hose, basically, where we have to take it all in. So the question now is, how do we build a career that stays valuable when so many things on this landscape are changing? It can feel overwhelming, point blank. I know that I have felt overwhelmed even now a lot of times when I feel like I try to stay up to date, but it doesn't matter how much I try to stay up to date, there's just always something new that's gonna be coming. So I started to think about why this happens to us as engineers, even as really strong or like senior engineers, where we just get overwhelmed so frequently with all of these new things. And a lot of times it's because we are trying to take in everything at one time. And if we're trying to consistently learn everything about everything and not being selective with our energy and narrowing it down, we are sort of like setting ourselves up for both failure and for burnout, which I know a lot of us have experienced in this industry as well. So the other thing is companies unintentionally reward product output over learning. Does anybody have a specific time or space set up that their manager has helped them with, or they're like, hey, I just want you to learn for a couple hours this week? For most of us, the answer is no. They want us to spend that time on code output and production. So the question is, how do we fix this in a way that doesn't give us anxiety, but also increases awareness and impact and actually fits into our busy job, so we're not just sitting there on every single weekend trying to learn all of this new tech stuff? The answer is to be adaptable and agile. So this is something that I've been doing periodically, and it's nothing super, super fancy. This is just a 4-category square. I do this in Notion. You can do it on paper. It does not have to be anything fancy. But basically what you're going to do is have a 4 square of watch, trial, adopt, and hold. And then maybe once a month, you're gonna spend, I'll say an hour or even an hour and a half, just figuring out what those new things are that you're interested in, writing them down and documenting them, and then creating a separate time and space for yourself when you're free, when you have the capacity to go through and explore them. And this isn't just, oh, I'm gonna go explore for however long and not see what happens. You're going to time box yourself. Let's say it's going to be 2 hours, and you're just going to say, I'm going to get from 0 to hello world and see exactly what's going on. What are the trade-offs? Was it good? Then at the end, you can say whether your trial was a success or not, and maybe you want to continue watching it. You want to continue using it. Or if you don't and your 2 hours didn't prove anything that you wanted to do, just throw it in the hold. You don't have to continue working with it. The next thing is going to be to build your meta skills. And the first meta skill that I know is not on here, but it's going to be learn how you learn best. If you don't already know how you learn best, that's going to be the very first step for you. But these meta skills basically allow us to learn faster and to stay relevant. So one of those is going to be evaluating trade-offs systematically. As an engineer, there's going to be so much information coming at you from your organization from so many different areas. People have so many different ideas. We have so many different ideas. We have to get good at stopping and saying, okay, what is this going to cost us and what is going to be the benefit? Because for every decision we make, there will be a cost, and sometimes there will be a benefit. So being able to systematically document what those are and weigh the pros and cons is going to help you document those better, also share them, and figure out what the best way to do it is for you and for your team. And the next thing is going to be to really hone in on design system thinking, especially today where we are working a lot with AI. Maybe now we're not necessarily worried about the smaller minutia parts of the code, but we need to be more systems thinkers and understand how different systems communicate with each other. System thinking transcends any programming language and framework, so you can always use those principles to tailor to one or the other. And then, like I just talked about AI, I'm always curious because the answer is always different. Who is using AI in their daily developer workflow? Okay, that's a lot more than normal. I've been some places where there's a lot more hands down. And I know it's like some people don't know where it fits yet in their workflow. Some people have organizations that don't allow them to do it. I think the key is trying to figure out what works for you. So maybe you start somewhere small with maybe doing something like scaffolding your code, something that's easy for you to say, yes, this is right, or no, this is not right. I like it to generate test cases, maybe a little bit of documentation or readmes. Overall, whatever you decide to use it for, the goal is to understand how it fits into your workflow specifically. If you're not a person who wants it to build whole features, don't use it for that because it's just going to cause you to go back and have to refactor. But understanding what the capabilities are, things like prompt engineering and context engineering are also going to be a lot more beneficial for you to understand as we get farther in this day and age where we're not really turning back from AI. And then as we solve, one of the skills that always is going to be more beneficial to us is human skills. The communication, the leadership, and the curiosity are our biggest assets as developers. And tools change. We know frameworks change. I started with Angular, now I'm on React. Who knows what it'll be in 5 years? But those leadership skills that I have and communication skills, I don't have to change them from framework to framework. So it's really important for us to spend time honing those two. So one last thing about it with our two new favorite developers. Alex is excellent, but they're reactive. Every single time a new tool comes across their desk, they're like, hey, I gotta stop and figure out what this new tool does. And then that leads to a cycle of burnout. They kind of don't want to pivot to new things anymore because they have put themselves in a rut where they're afraid of it because they know that it's going to be a long time sink. But on the other hand, we have Sam, who is a little bit more deliberate about what they're doing. They use that 4-square framework of understanding what they want to adopt, and they're watching, and this allows them to be a lot more organized. So when something new comes across, they document it, but they don't necessarily act immediately. But when they do find something that's useful, they have the time, the documentation, and everything to prove why we should go ahead and adopt this new technology or this new feature. Again, both are smart, but the difference is one of them has a framework that makes them a lot more efficient and causes less burnout for them. So we've explored how to adapt without burning out and how to turn that adaptability into a plan. And it's just one of the things that's going to allow us to level up. But what we really have to think about is how these tools that we have sort of like combine under pressure. Because I think all of us at a lot of times are under pressure, whether it's a deadline, people wanting us to get out more work and we don't have more hours in the day. How do we use these skills to create a plan that is feasible for us? So let's first start with communication. This is going to be the loom that makes your technical work visible, and reframing your proposals and outcomes, like we talked about a little bit earlier. This is going to what is transferring your engineering terms into those business terms to the right people so that they can say yes. Then we are going to handle ambiguity by asking better questions. I don't know about y'all, but I used to be really bad at getting a feature and then just being like, 2 points. Never was 2 points, always a lot more points than 2. If we're gonna ask more questions, we are going to ask what pain we're treating. We're gonna ask how we know it worked well, what that acceptance criteria is going to be. We're gonna ask about our customers. We're also going to knowledge share at every space that we can, not just for other people on our team, but for ourselves as well, because knowledge sharing is gonna be our leverage. And then we're also going to collaborate with other folks as well, and not just engineers. We want to understand the other disciplines and understand where they fit into this process. And then finally, ownership. We are going to start owning our products. We're going to start owning more than just our code base. We're going to start owning features. We're going to start being more proactive about who our customers are, and we are going to treat them as if that whole package is our feature. So you'll start to notice that these threads really start to enforce each other. I could get into a whole talk by itself about how all of these 5 features enforce each other. But the key is, if you think about it, communication is going to reinforce almost every single other thread that we have here. So getting really good at these and knowing how they work with each other is going to be really important. And then I have one small last challenge for all of you. This was a lot, and it might sound overwhelming of like, okay, well, how do I actually start to implement this in my day-to-day? You can just pick one thread. Maybe it's communication, maybe it's knowledge sharing, handling ambiguity, whatever it is. Just pick one, and over the next 30 days, try to start to hone that in. So if you notice maybe like your code base has a lot of things that maybe you just know, but they live in your brain, start documenting some of those things and start getting like a repertoire or a library of those things, and then start sharing them. And then you'll notice as you start sharing them, you'll start to collaborate with other people. Maybe they'll have other questions, and you'll be able to build more connections that way. So we've covered a lot of different things today in our 5 different threads, but if I had to boil it all down to a couple of different things, the first one is going to be, no matter what you do, try not to speak in code. Don't just talk about the code itself, don't talk about the implementation. For the people where it matters, speak in the outcomes. What is that person going to need to know in order for you to say yes? You're doing the code, but what is the ultimate goal? What are you actually trying to do? The next one is going to be to become a T-shaped engineer. Make sure that you are still increasing your depth and your technical knowledge, but also try to expand that top bar as well, where you're collaborating and learning about other disciplines too. And then I want you to create a personal tech radar where you can not just have a little ADHD like me and dive into all the new technology, but be aware of it, be aware of what's happening and when you might want to start adopting it, and make sure that you time box yourself appropriately. And then our 5 threads, which were communication, knowledge sharing, handling ambiguity and collaboration, and ownership, it's important for us to start honing those in so that we can work with them together. Okay, in the end, developers, all of us, we're good at coding. We got the code. But a lot of times the hard part is not the code, it's the people. It's the corporate politics that we have to deal with sometimes. And I know that's why a lot of us are engineers, is because we don't like to deal with people, we like to deal with code. But it's important for us to, oh my bad. It's important for us to really still understand those human aspects of code so that we can help our work move faster, so that we can have more visibility on the work that we want to do, and that is going to help us become better and more senior engineers. Thank you.
Thank you so much, Bree. That was a really insightful talk. So we are out of time, so we don't have time for the QA session, but it's lunchtime, so you can talk with Bree, and remember that we have today
And then 6 years ago, I moved to Oslo, Norway to work. I wrote 3 books during the pandemic because I couldn't go home and I want to make myself productive. I co-written 2 of them and also Microsoft MVP. And this one here, I'm doing the proofreading and testing of the certification in React. Okay, so let's be honest about the current state of CSS. Most companies have accumulated years of SAS that nobody wants to touch. We've all been there, afraid to delete the class because it might be used somewhere, and the build times keep getting longer, and every new developer needs weeks to understand the naming conventions. So this is the reality we're trying to escape. So how Tailwind eliminates this? No naming needed. Everyone writes the same utilities. No conventions to debate. No naming to mess up. No inconsistency possible. It looks like that it's similar with Bootstrap CSS. So Bootstrap gives you, but actually not really. Bootstrap gives you a pre-built components that you customize by fighting against them. On the other hand, Tailwind gives you utilities to build exactly what you want from scratch. That's why Tailwind eliminates naming conventions. You're not creating new CSS classes, just combining existing utilities. So there's a new version of Tailwind. Actually, it's not new. It's been a year now, so Tailwind version 4. It isn't just an update. It's a complete reimagining. The new Oxide engine built with Rust delivers performance that feels instant. And these aren't marketing numbers, by the way. So these are real-world improvements. Incremental builds are now measured in milliseconds, not seconds. This means your hot reload is instantaneous, keeping developers in the flow state. And let's address the concerns head-on, because a lot of front-end engineers have comments regarding the way you write Tailwind CSS, especially before, like 3 years ago when Tailwind is fairly new. But the HTML looks messy, right? That's what most of the time we say. Yes, the HTML has more classes, but it's self-documenting, just like TypeScript is self-documenting, and TypeScript been hated by JavaScript developers before. So you can see exactly what styles are applied without hunting through files. What about reusability? So it happens at the component level where it belongs. What else? We need our custom design system. Your design system becomes stronger with Tailwind's constraints. Our team knows SAS, of course, and that team that who knows SAS, they'll be begging you to not to go back after a week of with Tailwind. I've seen it happen dozens of times. So here's a real-world example every front-end dev can relate to. So traditional, as you can see it here, traditional SAS with files scattered across your project. You need variables, mixins, and components files. Making changes requires understanding the entire cascade. Tailwind 4, everything is right there in your component. No context switching, no file hunting. Your IDE gives you autocomplete for every utility. And when you change something, you see it instantly. Zero config. So this is actually a game changer for web developer teams. Version 4 automatically detects your content files. No more maintaining long global patterns. It respects your git ignore, exclude binaries, and just works. The entire setup is one line of CSS. So compare this to the config files, post-CSS setup and plugin management of version 3 Tailwind, or the Webpack configuration needed for SAS. So in Tailwind version 4, one file only, your global CSS file. This reduction in configuration complexity means fewer points of failure and easier onboarding. What else? Hat reload is instant. So it's not fast, but actually instant. So the Rust-based engine eliminates JavaScript overhead entirely. This isn't just about developer experience. Faster builds means faster CI/CD, right, in the pipeline, which means faster deployments. So in version 4 embraces modern CSS features that weren't available when version 3 was designed. For example, container queries let you build truly responsive components that adapt to their container, not the viewport. The new color mix function and LCH, color space, give you programmatic color manipulation without JavaScript. What else? Cascade layers solve specifically issue once and for all. I hope you can see. It's too dark? No, because there's text here. Can you see it? You can still see it. Okay, so the cascade layer solve specificity issues once and for all. And these aren't experimental features. They're production ready in all modern browsers. Let's go to design systems. SAS design tokens before. It's like this. So with version 4's, Tailwind 4, at theme directive, your design tokens live in CSS, not JavaScript or SAS variables. They are real CSS custom properties, which means they can be dynamic, changed at runtime, and even animated. And the OK's LCH color space ensures consistent perceived brightness across your palette. Your entire design system becomes type safe. In type safe, it gives you code completion with IDE support. No more typos in color names or spacing values, because when you control space or when you're writing it, you can see it right away what to choose. When you can see it later. And let me show you how fast we can build production-ready components. This dashboard card would typically require multiple SAS files, but with Tailwind V4, we can build it inline. So notice how the hover states, as you can see it here. Responsive behavior and animations are all collocated with the component, so that's those pseudos. So no context switching, no file hunting. The component itself contained a portable, copy it anywhere, and it just works. Yeah. And you can customize your styling in Tailwind that will lead to cleaner HTML code, and this will be in cascading order, so you will have consistent architecture, and these are not arbitrary. You have to write their names. Again, the at theme, it's here. At theme design tokens as CSS variables. These automatically become utilities you can use in your HTML. At layer, that one, at layer, I'm sure you can see. Okay, I have my mouse there, so it's good. So at layer base, add global base styles for HTML elements, runs in Tailwind's base layer. Just let the lowest specificity, best for typography defaults, element resets, global styles. And you also have these add layer components. So add component classes for reusable pieces of UI, runs in Tailwind's components layer. So this is the medium specificity. No type safety here because you're not creating utilities here, by the way. And another one, at utility. So create simple custom utility classes. Runs in utilities layer. This is the highest specificity. Means it overrides components. So best for single-purpose utilities, Tailwind doesn't provide with type safety, so you're going to get type safety here. In Tailwind, you can see when you hover your mouse to the utilities, the real CSS there, as you can see. And then you can also get type safe or code completion, or you can see it here, right? So there's no more typo error. And then if you Control S, you can see the changes right away that turns to blue. So this is your Tailwind. in action. And then, there's this thing called ShadCN. So why ShadCN became popular? ShadCN UI's success proves the utility-first approach works at scale. It's not a traditional component library. It's a collection of copy-paste components built with Tailwind. This gives teams complete control while maintaining consistency. And this is fairly new, guys, if ShadCN is new to you. We are used to UI libraries like component UI libraries. We install it and install and then use it. Here is, you can install it also like that, but it's called transparent model design. What is transparent model design? When you use it, when you npm install it, or actually you don't need to npm install, you can manually copy it because it's in your project. For example, button. It's in your project. It's not hidden behind this library that you import. So basically, you can customize it because the code is right there. You need let's say a navigation bar or a badge or a pill component. It lives in your repo, and you can see it there that how it's being written, and now you can edit it right away, right? So that's the difference between this one. That's why a lot of people use it, because it's highly customizable because it's in your repository. And you can see it here. So that's the core principle of transparent model. Anyway, this is ShadCN UI in action. When you add a component from ShadCN, it goes to a default folder or what you define, and it's just import like this. There you go. I'm using React here, but ShadCN is available in Vue.js and Angular. So you can easily edit your component because the code is there in your project, right? It's not hidden. And another shot from WebStorm, actually how to create a reusable component, reusable CSS classes, reusable component if you are not using and also Angular. Version for SAS is common, right? SAS common, SAS also user before. Yeah. Or just CSS. The Tailwind side, zero custom CSS. Everything is co-located. It's accessible by default with ARIA states. Copy this into any project and it works immediately. The power of utility first, complex UI with zero CSS files. And it's so good that, right, you can just copy it and then put it in any component. It's just gonna work right away. It's very composable. Yeah. And this is where Tailwind really shines for your web application teams. So instead of managing complex media query, mixing and separate responsive CSS files, everything is inline with simple prefixes. So years ago, of course, I'm one of those people like, oh, I don't like this Tailwind because it's kind of messy, but actually it's not. And then when I realized that it's so easy to create responsive design in Tailwind, like this is it. The mobile-first approach is built in. You design for mobile by default, then add breakpoint prefixes for larger screens. This ensures your app works perfectly on mobile devices. And the best parts, and it works. So look at this. MD colon means tablet and up. LG colon means desktop and up. It's that simple. You can see exactly how a component behaves at every breakpoint just by reading the classes. No more jumping between files to understand responsive behavior, right? This is also the main selling point of Tailwind. So, yeah, the ecosystem is all in. Vercel v0.dev generates Tailwind by default. GitHub Copilot trained extensively on Tailwind patterns. Component libraries, SADCN, Catalyst, Tailwind UI, frameworks, Next.js, Remix, Nux, all default to Tailwind, by the way. So all modern frameworks are defaulting to Tailwind. AI tools, Claude, ChatGPT, write better Tailwind than custom CSS. And I'm a user of Tailwind. I'm a user also of GitHub Copilot. Who's using GitHub Copilot here, day to day? And half is not using any AI helper. Do you know that because I'm using GitHub Copilot, right? And how many weeks is your sprint? 2 weeks, 3 weeks? 2 weeks? 2 weeks? I can finish it in 2 days. Copilot, Tailwind. Yeah. Don't tell my boss. I'm finishing our sprint in 2 days. Just me. All my tasks done in 2 weeks. Not because I'm good. I'm just using the tools that I can use. GitHub Copilot, Tailwind, SADCN, and my boss, they don't give a bread. They don't care. In short, they don't care whether if I'm writing it by hand or the AI is writing it. But the point here is I can be super productive finishing a 2 week of 10 days of work in just 2 days. But this is not for junior developers, by the way. I just warn junior developers to. It's hard for junior developers to use AI or Copilot because it's hard to know if the Copilot is spitting BS or not, right? So if you're a senior developer and you're using GitHub Copilot, it's so good, right? Just keep reviewing what the Copilot is spitting out. So migration strategy. So migration doesn't have to be a big bang. You start by running Tailwind alongside your SAS or your vanilla CSS. They coexist perfectly. Build new features with Tailwind while maintaining existing SAS. As components need updates, migrate them. So yeah, let's recap what Tailwind v4 means for your enterprise. It's not just faster, it fundamentally changes how teams work. The zero config setup means less to break. The design system integration means consistency at scale. The ecosystem support means you're joining an industry standard, not taking a risk, because all modern browsers are shifting by default to Tailwind, right? And teams using Tailwind v4 ship faster with fewer bugs and happier developers. Yeah, this just like recently, I'm not sure if it's recorded. Okay. But for sure, my teammates are not watching this. We deployed a huge application, and the only front end is me, by the way. And I think I only wrote 5% of that code by myself, and the rest are AI, Copilot, Claude. Oh yeah, and it's and all I can hear from my boss, from the project management, Devlin, you're so good, you're so fast, and everything works. We love this design. It's all praises, and I'm just using Copilot, and it works for me. I'm not sure if you're going to apply that in your team or as yourself as a developer, but just to give you an example, if AI works in production, yes, it's a huge application, and it's a platform. We built an internal platform with applications worth millions of dollars deployed into that application platform, and 95% of, actually 98%, it's just very few code that I wrote, mostly AI. And yeah, and Tailwind SADCN, because it's really fast. Okay, key takeaways. Tailwind v4 isn't just an upgrade, it's a competitive advantage. In today's market, that's a competitive advantage you can't ignore. So the barrier to entry has never been lower. Install Tailwind v4, add one line to your CSS, and you're ready. You start with one component, one feature, one page. Your team will quickly see the benefits, and adoption will happen naturally. And if you're using VS Code, their official Tailwind CSS IntelliSense plugin includes a dedicated Tailwind CSS language mode that has support for all of the custom @rules and functions Tailwind uses. For WebStorm users, it supports Tailwind CSS by default. Resources, so the resources are incredible. ShadCN for components, Tailwind UI for templates, LLMs for coding. My number one choice is Claude, the latest Claude. But I was like talking to Guillermo, right, the CTO of Vercel. And he said GPT-5 is good in front end. But I have to try that to myself. So yeah, the future of CSS is utility first, and that future is here today. If you want to see my social links, it's here. Yeah, gracias.
¿Alguien tiene preguntas? ¿Preguntas?
Yeah, I used to use Tailwind when version 4 came out. I haven't used it that much lately, but I have a question about libraries like TW Merge to make to add some Tailwind to the original component, for example. And I read that this library is used to slow down Tailwind performance. Do you know something, if that's true or is not making any difference?
Okay. Which library is this again?
Like TW Merge, and I don't remember the name of the other one. It's like Merge Tailwind classes. When you have
okay. Tailwind Merge, yeah. So that's a utility that it's installable. I think it's included in ShadCN. But before that, I'm already using that as a utility myself, like my own code. And what it does is, if you have the conditional state and you want to switch different styling, that is slowing it down before. I heard that before, but not anymore since last year.
Okay.
But in my case, I don't see any performance problem with that. And that utility it's so important that you don't want to remove it for the sake of gaining few milliseconds or 1 millisecond, right? It's very important for not messing or not creating any design bugs, because in real world you have these conditions like if else, and then if this is the design or this is the class, right, this is the color, or else this is the color, like fading a button or making it gray out or disabling things, right? So it is, yeah.
Okay.
That's my take on that part.
Awesome. Thank you.
Yeah.
Someone else has a question? Preguntas? Well,
Thanks. Well, yeah. Is there or does exist a set of architectures or patterns so we can implement Tailwind, keeping the styling details organized? I mean, I think there are two problems that are not really problems that as developers we see or we encounter. That is, we don't like seeing the classes in the JSX. We try to hide that implementation, the details of the styling. And that's one of the things we used to don't like about Tailwind. But I wonder is there a way to hide or to abstract that styling implementations, so the main JSX keeps visually clean. While all the classes are, I don't know, in a separated file or imported from a global.
Yeah. That's a good
concept.
question also. So how do you make your Tailwind, your front end, your HTML clean? Is there like a best practice in Tailwind? Because your concern is the readability, right? So the best practice is, it's like what Shadcn is doing for you. It's separating, for example, the button there is there. You abstract things, you create a reusable component for that so that you don't have to constantly create these long utilities in every time you write. Also, the custom part there, so you can customize it and put it like in your global CSS. That's also one thing. And another thing is there's a VS Code extension that will clip the CSS, not hide, but just like really, and then a Tailwind icon. So even though it's long, it will just shrink it for readability purpose, since that's your concern. So yeah, that's my answer. Customize it using the global CSS, the way you customize in Tailwind, create a reusable component, and then the extension, VS Code extension, to disappear it, to hide it.
To make it more compact visually.
Yeah, visually, yeah. So those are the three things I can say, yeah.
Is there any other question, or I will like... thanks. Yes, another question. Related to this approach, I've tried, I'm using Tailwind. I want to use it. And not for production, I'm using it for my own projects. And I like it because we are productive, it's stable, it works, you know. But, well, talking again about the visual compact, I've tried to have a dictionary, a file with a dictionary of utility classes, so I can just import them and use it, well, in the class prop of the tag. But it works, but I'm missing the VS Code help that autocompletes the utility classes in the dictionary, because it doesn't detect that I'm writing Tailwind classes. So is there any TypeScript or utility type I can use on constant, so I can say, okay, I don't know, I will have the constant named or called main sidebar, and sidebar classes equals to or double dot colons. Tailwind utility class equals to, and
yeah. I think I showed it. So the question is if I can customize, create this like dictionary of my own, your own in CSS design, and then make it appear in the VS Code when you type like autocomplete. I think I mentioned that the @utility is a way to do it if you want to make it appear in the along with the default Tailwind utilities, right? And then on top of that, you can add more utilities by using the for the customization, and then that's how you do it, yeah. And it while you type, yeah, and as long as you have the Tailwind, the CSS VS Code extension, yeah, of course. Mm-hmm.
So you have a last question here.
Oh, yeah.
And this will be the last one because we are out of time.
Okay.
Thank you. So I got a question, or I wanted to know your opinion regarding like other tools than Tailwind that probably does like a little bit of this pre-compile or already written CSS, which is Panda CSS. I don't know if you have heard about it. So I was like wondering, because I can see that using Tailwind is kind of a little bit of learning curve, because you need to read the whole documentation and like kind of see like the classes and all that stuff. And when using Panda CSS, it's basically writing CSS, and you're going to be pre-compiling all these classes into a single file. So I don't know if you have seen a use case of using one of the other, or do you prefer totally Tailwind at all? Like,
Okay, so the question if I've seen other libraries being used along with Tailwind,
yeah.
right? Like the Panda CSS, and there's Daisy. I think there's another one, Daisy, which is very popular. Daisy is a CSS a library on top of Tailwind CSS. It has pre-built classes also, which is very useful. But the Panda CSS, it's more on I see developers using the Daisy than the Panda CSS. So, and yeah, that's all I can say about it. But in my case, in my projects that I deployed, it's pure Tailwind and ShadCN, because the AI changed the productivity and the way we code nowadays. That all the models are trained in Tailwind. They scan the whole internet, right? But on top of that, they're being additional trained using React and Tailwind CSS. It's so good that I can just prompt it and it write it for me. Like basically, I just mentioned it earlier. I didn't write 98% of the code in the huge application I made, and they test it. Everyone likes it, and that's for me. That's the goal, and make the customer happy, because they don't care whether you're using Tailwind CSS. Actually, they don't care if I'm using Tailwind or not. They just want to deliver. They just want to deploy their application on time. Well, actually, what I did is I was like 2 weeks earlier than their target date. For 2 weeks, I'm not doing anything. I'm just sitting and being paid because I finished all the things before there, and they're very, very happy in that sense. Yeah, this like guys, AI changed the game, and I encourage you to try it if you haven't used GitHub Copilot or anything, and try to just keep using it, because there's a lot of learning you need to know, and how prompt engineering works, or how AI behaves, or how they respond. Just keep using it, and you'll see like, okay, AI are dumb if I didn't include much context. It's all about context in AI. And another example, if Tailwind will release 4.2 tomorrow, I can use it right away in our production. For example, the React 19.2 was released in the morning, and I just asked the Copilot to scan the whole project and then add these new features of React in places that make sense. But I downloaded the markdown files the huge markdown files of the release documentation and the blogs about it, because I need to feed the AI the details of this 19.2 version of React. Otherwise, it doesn't know it, right? Because AI models, most of the time, it's more than a year. Their knowledge is more than a year. So I need to make it to attach a document of the blog markdown file that the React meta engineers posted, and then feed it to. And after 4 hours, like in same day, I have my code on the modern React. Everything's new. Everything's like, yeah, it's just changed everything. The AI, yeah. So that's
Thanks,
it. Thank you
David.
for listening.